For today's video, we will be reviewing some of the vocabulary from yesterday's vocab review on parallel lines and angles. We will spend today and the next lesson on making sure that we can do calculations by understanding the relationships that exist when lines intersect. So for today's announcement, it's the day before Halloween, so happy Halloween, everyone. If you have not yet done yesterday's vocab assignment, please go ahead and do that first. You need to know that so that the terminology will not be too much to handle today. Then, if you've already done that, you can move on, but we will be going to Delta Math. There's an assignment called 1030 Lines and Angles Vocab Practice. We will be continuing more with parallel lines and angle relationships in the next lesson, but certainly we need to review all that terminology from the vocab practice. So I do have a template here that I'm going to be using that will look like some of the problems, just because on the screen sometimes it may be difficult because you might want to write, but you can't. So you can either draw from the Delta Math assignment, but the same figures are being used over and over. So if you click on it and open it, you can print it. But I just took screenshots of this diagram, which we're going to be answering questions about, and made a bunch of them. So it's like 2 pages of them. You don't have to print them. You don't have to write them all down. Some of you will be just fine if you just visualize or just do the problem on the screen. But just in case you need something tangible to write on, you can. Work needs to be submitted for today's assignment, and that's all you have to do is the Delta Math assignment for today. So I'm going to go ahead to the Delta Math assignment. I know you might look at it and go, oh my gosh, there's so many problems. It's really not bad. There are 29 problems, but I'm going to do a bunch of them with you, and it's really just answering quick questions. So not any really calculation other than maybe a quick addition or subtraction. So it'll be pretty easy. So just as a quick recap, I am going to review a few things. And if you watched yesterday's video, then we talked about parallel lines and angle relationships. I just want to review a few things with you so that when I'm going over problems, you'll be really clear on some things. So one of the terms we talked about yesterday was vertical angles. Vertical angles are angles that are right across from each other. So this angle and this angle would be vertical. So I'm going to use my black pen and put vertical. So if they're right across from each other, so think about if you have 2 lines that intersect, no matter how you move those lines, the angles across from each other, like over here and over here, will be congruent. Okay, so I'm going to put an arc to show that they are also congruent. And that can happen anywhere where they're right across from each other. So it could be here and here are congruent to one another. This angle and this angle are congruent to one another because they are vertical, etc. This angle and this angle are congruent to each other because they are vertical. So that's what you need to understand in terms of vertical angles. Let's see. Also, vertical angles. What else we got here? Supplementary. Just want to remind you of the fact that 2 angles are supplementary if they are a linear pair. So this angle here, ACB, and the angle BCE, these add up to 180. So I'm going to call that X and Y and say that X plus Y equals 180. So supplementary means that they add up to 180. A pair of angles that adds up to 180 degrees. So that could happen here and here. I could do that, X and Y, and they would add up to 180. Because this is Y and that's vertical to that one, this X and Y add up to 180, etc. That X and Y, that's a vertical angle. So all the X, Y's would add up to 180. I hope that makes sense. So I can name them however I want. It doesn't mean that all the X's are the same, but in terms of being across from each other. Oops, I should have done X here. Y, these would be congruent, but together X and Y would add up to 180. So that's what it means to be supplementary. Complementary is when they add up to 90 degrees. So I'm just going to write this down so we'll have it ahead of time. Complementary So remember how supplementary add up to 180, complementary means they add up to 90 degrees. And so remember that, like, if I have an angle with a box, that means it's a 90-degree angle. If I split that into two, then if I call this A and B, then A plus B will add up to 90 degrees. So we need to be aware of that one. And then also the word adjacent. So I'm just kind of writing stuff in so we can review this vocabulary. Adjacent simply means next to. So if we consider the numbers here, angle 4, this one that's labeled 4 is next to E. So they're adjacent to one another. Doesn't mean they're equal. They are supplementary in this case. 4 is also adjacent to 5. It just means that they're angles that are next to each other. Okay? So just wanted to remind you of what the word adjacent means. All right, so we're just going to go through a few of these. And the first thing I needed you to be able to do is identify which angles are represented by, in this case, angle KHI. So I don't know why that's little. It should be a big. There it goes. All right, so if I'm wanting to know which angle number, so I have all these numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and they're all labeled without the letter, but that doesn't mean too much. It just means that we have a number to represent that angle. So things I need to remind you of. When we name an angle like KHI, it means that the middle letter is the vertex of the angle. So let me go back here. For KHI, if I'm talking about angle KHI, when I say vertex, it means that I have an angle where H is where the two rays meet. Okay, that's H, and they might label that K and I. So I is at the vertex of these two sides. So KHI is, look for the letter K right here. So this is K, H, and I. So angle KHI is right here. Well, if we consider that over here, and it says what number represents angle KHI, H being the vertex, is going to be this angle here. So that would be represented by angle 9. Okay, and so that's why I have this in case you want to write on it like I'm doing. Some of you will not have to do that. You can just look up here and go, oh, there's KHI. So number 9 would be the angle represented there. You just type in 9, submit your answer, and that's it. So I'm going to do one more, and then you can do a couple of those yourself. So which angle represents NKL? So K is going to be the vertex of that angle. So I want to locate N first. N is over here. Then it goes to K, then to L. So NKL would be this angle here, represented by number 12. All right. So just kind of getting you familiar, since we're switching gears from algebra to geometry, and remind you some things that maybe you just haven't seen in a long while and didn't want you to be unfamiliar. So there's 3 and 4 for you to pick on your own. And then I've got 4 with adjacent, so I'm going to do 5 and 6 with you. So it says, which angle number is adjacent to angle NCA? So I am going to refer back to my handout here and go, okay, and it says what number, I believe, right? Let's see. Yeah, what angle number. So looking at this here, for NCA, sorry, let me focus a little bit. Close your eyes, well, focuses. All right, so NCA, I'm going to take a highlighter. If I were like a kinesthetic learner, if I liked hands-on stuff, this is what I would be doing. So NCA, that's angle 1, but it says which angle is next to. Adjacent meaning next to. So if I want to know what angle is next to angle 1, I would choose angle 2. Is this angle ACB next to it? Yes, but it says what number. So we need to choose the number that is next to. So that would be this one here, which is 2. So 1 is next to 2. Not 3, because 3 is vertical to number 1. So if they ask me what angle is adjacent to NCA, I'm going to go, oh, that's angle 1. The one next to it is angle 2. Okay? So I'm going to just type in 2. So as you can see, not a hard assignment. Just kind of wanting to get you to get more familiar with the terminology. I think I did 5. Let's do 6. Another where it's adjacent. So some of you will look up here. Of course, if you want to use paper, you can. MNK. MNK is this angle here, which is number 13. So which angle is next to 13? The only one that's numbered is 14, okay? Yes, N is also adjacent, and 15 is vertical, but 14 is the only numbered one next to MNK, which is 13. So we would type in angle 14. Okay, so now you can go ahead and try 7 and 8. Next, I'm going to switch gears and do 2 vertical, and then you can try 2 vertical. Remember, we just talked about vertical angles are across from one another. They share the same vertex. They also happen to be congruent. So it says, which angle number is a vertical angle to IHK? So we got to look for I. Where's I? Over here. So IHK, this angle right here. So I'm going to do this on paper. And it's a numbered one, so vertical to IHK. IHK is 9, and vertical to 9. Remember when we did vertical earlier, they were the ones that shared the same vertex. They are not next to each other, meaning adjacent. They're across from one another. So vertical to 9 is 7. Okay? And I'll just do one more with you. Make sure you're clear on that. For number 10, which is vertical to ECB, here's E, there is C, and there is B. ECB is represented by number 3, and vertical to 3 is 1. So again, this is really just about making sure we're clear on vocabulary so that we can do calculations on in our next lesson. All right, so you'll do 2 vertical on your own. Now we're going to talk about the measure of a vertical angle. Well, remember what we said about vertical angles. What did we say about vertical angles? They are, oops, let me flip back here. Vertical angles. If you notice, this is obtuse and that's obtuse. These obtuse angles are going to have the same measure. But likewise, these vertical angles, because they are across one another, are going to be congruent to one another as well. And we would indicate that with 2 arcs. Okay, or whatever. We can't mark them with 1 arc if this one uses 1 arc. So the ones with 1 arc are congruent to each other, 2 arcs congruent to one another, etc. So vertical angles are congruent, and that was the vertical angle theorem. The theorems from yesterday's lesson dealt with the measures of the angle. Either certain sets of angles were supplementary, meaning they add up to 180, or certain sets of angles were congruent, meaning they were equal in measure. So in other words, if I tell you that this angle measure is 120 degrees, then we know this one is also 120. And because any two that form a straight line, we just talked about linear pairs. So if I tell you that x is 120, then y would be 180 minus 120, or 60 degrees. So 120 and 60. See how they add up to 180? So just a quick recap, that vertical angles are congruent and supplementary angles add up to 180. So it says that HEF, so we got to locate that angle. HEF is 92. And this is where your paper gets, if you're able to print it, it can be helpful if you need it. So H is here, E is up here, and F is here. So notice this is an acute angle. Recall that vocabulary, that an angle is acute if it is a measure less than 90 degrees, and it is supplementary if it is a measure more than 90 degrees, in between 180 and 90, I should say. So HEF, if that's 92, then it asks for what is the measure of AED, and that is also a vertical angle. So I'm just going to switch here. We can talk about this. So if HEF is 92, AED, because they are vertical, will also be 92. Pretty straightforward, right? Granted, it looks like an acute angle, and 92 degrees is above 90, meaning a right angle, but this is not necessarily drawn to scale. So again, if HEF is 92 and AED is vertical, then it will have the same measure. So these should be pretty easy. You literally are just typing in the same measure, right? So measure of this vertical angle if JKG. So this is the deal, though. They're not telling you it's vertical, right? That's your job to figure that out. So JKG, this one here, JKG. So if JKG is 98, what is the measure of LKO? Oh, well, LKO is vertical to JKG. So these two here, right here, not that I can really click, but there and there, are both the same measure. So they're both 98. All right, so you can try the next two that are vertical. Here I've got some that are supplementary. So it says which angle is supplementary to DEC. So I'm going to, in which angle number. Remember, supplementary, they're going to come from a linear pair. So I'm going to switch back here. From yesterday, remember we talked about linear pair. I'm going to choose, let me go back. See, was this numbered? This was numbered, and it says supplementary to DEC. So locate DEC first. So DEC, use a highlighter instead of a pen. DEC is 4. And they want to know which one is supplementary. Supplementary is the one that forms a straight line. So it could be E, but E is not a number, and they want us to find the number. So we're talking about these. So remember when I labeled like X and Y? If one is X and the other is Y, this is what I mean by a linear pair. Together they form this straight line. Okay? So 4 is a linear pair to 5. So they are supplementary. Okay? So notice right here what it says. Supplementary angles are adjacent. What does adjacent mean? Next to. So it's the angle next to it that would form a measure of 180 degrees, which is a straight line. All right, I'm going to let you try the other ones. Next, we're going to just identify angles with terminology here, where it tells us the measure of BCE is 84, and then we have to decide the measure of FCM based on what it is. So I am just going to flip back over. They tell me BCE is 84, and they want me to find FCM. That M, by the way, the little m, stands for measure. So this is the measure of angle FCM. That's what they want us to find. So F, they gave us BCE, and then they're asking us the measure of FCM. So FCM, they want us to find that measure. Well, what is true about the relationship between these two? Don't they together form this straight line? So they are supplementary. So that's kind of like an X and a Y I was telling you about. So really all you have to do is take 180 and subtract the one that you know. And 180 minus 84 is 96 degrees. So I'm just going to come back over here and go, oh, they're supplementary, therefore, oops, that one's 96. Of course, if they were vertical, they're the same angle. If they are supplementary, you subtract 1 to find the other. Subtract 1 from 180. Okay, and you'll try the next two. Then we've got some where you have to find the measure of different angles, and these are not the same picture. So if you want to take your paper and just flip it over, because remember, you don't have to submit any work. Some of y'all will be very good at just looking at it. What you should notice that here to find B and C, B is supplementary to 144. So you literally would just take your calculator, just because we haven't used a calculator today, why not? Love our little Calculate 84 app, if I can find it on my phone. So if I just take 180 and subtract the 144, oh, you're not even seeing what I'm doing. Let me switch back over. So if I take 180 and subtract 144, the other measure is 36 degrees, because 36 plus 144 adds up to 180. So that's really all you're needing to do here. So back here, so notice also that 144 is an obtuse angle, meaning more than 90 degrees. So it should make sense that the B, which is acute, is not 144 degrees, because to be acute means it is less than 90 degrees. So B is going to be the one that we subtract 144 from 180 to find, and that measure is 36. And C, because it is vertical, they share only the same vertex, which is the point where they intersect. They are not adjacent. But look, the obtuse matches this obtuse. So 144 is the measure of C also. And that's what you're going to do, is just find the measures of those using angle relationships. So here, I love that they do this. The highlighted angles are vertical, meaning they are opposite angles formed when two lines cross. And they're always the same size, which is the same measure, 144 and 144. However, a straight line measures 180 degrees. Angle B and the given 180 are adjacent, meaning they share a side, and together they make up a straight line. In other words, they are a linear pair. They form a line together right here, this angle here and this large angle. That's what we mean by all that. So again, we're subtracting from 180 and get 36. So all these are a little bit different. They're not all the same. But we'll do a couple more just to make sure you get the gist of it. So if we have to find 29, or we are given a measure of 29 in A, recognize that this angle here and then this wide acute angle, they form this straight line right here. Therefore, they are supplementary. So to get A, you'll just subtract 29 from 180. By the way, make sure you type it in as 180 minus 29. We do not get negative angles, which will happen if you do 29 minus 180. Make sure it's always 180 subtract the given angle. Okay, if they are supplementary adjacent angles. Next, here we just did a problem similar to that. Let's do, there are a couple that are complementary. That should be easy. And let's definitely talk about this one. So I'm going to sketch this on paper, and hopefully what you notice is that box which says that this measure here is a 90-degree angle measure. All right, so and it says find the missing angle, which is A. So I just drew it on paper. So what do we know? This time we don't have a linear pair, because that would be, a pair is 2, but we have how many angles? We have this 55-degree measure. We have this 90-degree measure. We have this acute angle here. But all together, these 3 angles form a straight line. So that means that all 3 of them add up to 180. So this box is like, you're supposed to understand, oh, that's 90 degrees. If I need to find A, then all it is 180, subtract 90, subtract 55. And that gives me a measure of 35 degrees. And that should make sense. The 3 of these should add up to 180, because together, if you take these 3 wedges and put them together, they're going to form this straight line. Okay? So that was 35 degrees. Notice as a degree symbol up here, if you were writing this on paper, you would put a degree symbol, but they already have it up here for you. So they explain that similar to how I did. And then you're just going to go through and finish all the remaining problems, guys. You should be good to go. Hopefully this is really helping that terminology sink in. This one here, I'm going to challenge you to figure that out based on vertical angles. And if you consider, it almost looks like a x-axis and y-axis. So what do y and x add up to? I wonder. They must add up to 90. And if I want to find this angle here for x, what do I notice about these angles? They add up to 90. So I'm going to see if y'all can figure that one out. That's a good problem there. And then lastly, this should be pretty easy. You've got a set of perpendicular rays here. This is a angle here that is 90 degrees, where one is 57. Therefore, A should be the difference between 90 and 57. These would be called complementary angles. Two angles add up to 90 degrees. All right. Well, good luck with the assignment, guys. And, of course, let us know if you need any help.